Now we come to lecture 5, in which we will cover the remaining types of clutches. First, let us see what are the dry and wet clutches. Multi-plate friction clutches are either of the wet type or the dry type. Now, what is the dry clutch? Dry clutch is the one which we have studied in the previous lecture. Consists of driving and driven plates, two sets as I said, connected alternately to the input and output shafts. These input and output shafts are flywheel shaft coming from the engine, and output is clutch shaft going into the gearbox. The driven plates are lined with friction materials similar to the single plate clutch. The driven plates which ultimately drive the clutch shaft going into the gearbox. The operation is similar to a multi-plate wet clutch, yet it is not run in a bath or oil. That's why it's called a dry clutch. In wet clutch, the operation is the same, except for that there is a bath or oil inside the clutch. The number of frictional and metal plates to transmit high torque, as we had studied, single plate and multi-plate, we increase the number of plates to transmit high torque, which we have already studied. Alternately, that is the plates, alternately the sets of two fitted to the input and output shafts as before, that is engine and the gearbox shafts. The plates are immersed in oil bath, having grooved surfaces. This is the difference between the dry and wet. The clutch lining, clutch plates, they have grooved surfaces. The grooves are on the facing for allowing the oil to pass, to permit oil flow. And what does the oil do? It dissipates heat. Now let's compare it with the dry type. Compare the wet clutch with the dry clutch. Better heat exchanger, that is metal to oil versus metal to air. The heat exchange in metal to oil is better than metal to air. In trucks, we have lower torque peaks. The lower torque capacity is due to the low coefficient of friction due to the oil. In fact, the wet clutches are 35 to 50% of the dry clutch torque for the same size. Now, let us come to another type of clutch, the electromagnetic clutch. Example is, few Renault car models have this type of clutch. Let us see working. This is the engine shaft, means the propeller shaft coming out from the engine, and always the flywheel is connected to the engine shaft. In the flywheel, there are windings shown by this cross section. On the clutch shaft, this is the pressure plate. On the clutch shaft, the pressure plate, this is the clutch plate, which is free to slide on these grooves. Operation is simple. When the current is fed to the windings, they get energized, and the pressure plate is attracted to the flywheel with the clutch plate in between, and the drive is transmitted. The clutch release lever in the gearbox, and how does it operate? There is a switch, operating switch. When the driver holds the gear lever, there is a switch on it. When he wants to change the gear, the switch gets operated, current is cut off to these windings and the clutch is released. Got it? When the driver, I'll repeat, catches hold of the gear lever to change the gears, the switch is operated and the current is cut off to these windings, thereby disengaging the clutch, and he is free to go to the next. Now, the electromagnetic force of this winding is regulated by the accelerator pedal through a electrical resistance. That means the current, the switch is below the accelerator pedal, and the accelerator pedal is, the switch is activated, and the resistance gradually cuts the current, thus increasing the electromagnetic force in the winding. Clear? Next we will come to the centrifugal clutch. This type of clutch is best suited in remote operation since no linkages are required to control its engagement. It's best suited in remote operation. No linkages are required, and this is generally employed in such vehicles. Now we come to the centrifugal clutch. Kinetic scooters, most of you must have driven. Keep that in mind while understanding this, and the reception will be better. The centrifugal clutch uses centrifugal force instead of the spring force to keep in engaged position. In the earlier clutches we saw, single plate, multi-plate, there were springs, radial springs all around, which kept the clutch in engaged position. Here there is no clutch plate, no clutch pedal. The operation is automatic depending on the engine speed. You will see how. And also, therefore, the feature is that you can start the vehicle in any gear just by pressing the acceleration pedal. Let us see the construction and its characteristics. This is the engine shaft connected to the flywheel. There is a weight A, which is pivoted on a bell crank lever. This is the bell crank lever hinged at B. C is a plate. This is the clutch plate. This is flywheel. This is the clutch plate. This is a spring E. Now, when a force is applied, the weights due to centrifugal force move outwards, pressing the bell crank lever onto this plate C, which ultimately against this spring force presses against the clutch plate. the spring G, there exerts a force Q which is constant at all engine speeds. So, how is the clutch disengaged? When you lower the speed, engine speed, accelerator you reduce, this comes down, centrifugal, the weight comes back to tries to come back to its original position. The bell crank lever releases this force P, and the spring helps it to the plate to move back, thereby disengaging the clutch. Let us see the characteristics of this clutch, centrifugal clutch. This is the engine speed versus the centrifugal force. Now, due to this spring G, at say 500 RPM, the clutch is kept disengaged at low RPM, let's say 500. As the force P increases by increasing the engine speed through accelerator, it follows this proportional to the particular speed. This is the force P. Force P. As you increase it, the force P will increase, thereby engaging the clutch. Force Q, as I said, is constant due to the spring, which is shown by this line. So engine speed is increasing, the force is increasing. Now, this flat line is caused by the stop H. It limits the weight and makes the weight stop here. This is represented by, that means further force P cannot increase. This is the maximum force P which can be exerted at a particular engine speed. That is, let's say 1500 RPM is you get the maximum speed. Now, what is the net force on the friction lining plate for various engine speeds? This is shown by the firm line, this line. This line shows the force on the friction plate, and it has to vary with the varying engine speed. This is the characteristics of the centrifugal clutch. We'll read through this. Uses centrifugal force instead of spring force to keep in engaged position. No clutch pedal required. Operating automatic operation depending on engine speed. Can start vehicle in any gearbox by pressing accelerator pedal. Construction. We've seen characteristics. The force is P is directly proportional to the centrifugal force as explained at particular speed. Force Q is exerted by clutch disengaging spring. This is the clutch disengaging spring and is constant at all speeds as explained. The firm line is the net force on frictional plate lining engaging flywheel for various engine speeds. The upper end of the curve is made flat by means of the stop H, which limits the travel of this weight and limits the travel of this weight and limits the centrifugal force also. Now we'll come to the next fluid flywheel. The last type of clutch as per your syllabus is the fluid flywheel, which is shown here. Let us see the construction. The fluid flywheel or the hydraulic coupling, it's also called hydraulic coupling as it is frequently called, has been used in cars employing automatic transmission. Automatic transmission, it's the fluid flywheel which is operating. It consists of two members, the driving member and the driven member. The driving member is attached to the engine flywheel. This is the flywheel. This is attached to the engine. The driving member is attached to the flywheel. And the driven member to the transmission shaft. The output shaft going into the gearbox. The two members do not have any direct contact with each other. Do not have any direct contact with each other. The driven member is free to slide on splines. This driven member is free to slide on splines on the transmission shaft. These are the splines on this transmission shaft. The two rotors are always filled with suitable viscosity oil. Suitable viscosity oil. These are provided with radial ribs to form a number of passages which avoids the formation of eddies. These are radial ribs for the passage of oil. This is in fact the rotor of the, you can call it the rotor of the fluid flywheel. This is the cut section. This is cut section from the side, front view. To form a number of passages which avoids the formation of eddies and also guides the fluid to flow in the desired direction. So, as you can see, this is the driving member. Since it's connected to the engine shaft, it is rotating at a speed, let's say N1. This is a simplified diagram, N1. And gradually gradual contact when the both are rotating, and the fluid is the medium instead of any friction plate or lining, and gradually the oil goes into the driven member, and gradually as the speed picks up, they both will ultimately reach the same speed, let's say around 3000 rpm. From the characteristics you will see percentile slip. That is, slip means amount of oil that is going or not going into the driven member. It will be 100 because this is initially stationary and this is driving at N1 rpm. So as the speed of N1 is increased, the percentile slip after a short while, it falls and the driven member starts getting its rotation. The rotation to prevention of eddies, as I said, is controlled, the direction of motion is controlled by these grooves which are provided in the rotor. Automatic clutch action. Conventional type friction discs when the battery current is supplied. There are conventional type friction discs. When the battery current is supplied, an electromagnet, there is an electromagnet in the flywheel which operates the pressure plates, which engages the disc, thus transmitting the torque. Electromagnet in the flywheel. Current is supplied, engages the disc. Disc in turn allows the fluid to pass into the driven member, and the driven member gradually, as the speed increases, gradually attains the speed through the force of the fluid and through the passages provided. With this, we finish the clutches and also the end of Unit 1. In the next lecture, we will start with Unit 2 as per your syllabus. Thank you.